Let's get started with an introduction to testing where we talk about how, what, and why we test. I want to get off and be as clear as possible. We could be talking about two kinds of testing. We could be talking about manual testing and automatic testing. Now, manual testing is usually done by a human. The advantage here is that there's no overhead, right? You're programming along and you can go ahead and you can pull up your application, you run it in development, you click around. Great, you're testing the application. The problem is that this is time consuming, right? You have to go ahead and you have to click around, and that's not great, and it's error prone. The larger your application gets, the more clicking you have to do, the more likely you are to forget to test some sort of feature and whatnot. By contrast, automatic is harder to set up. There's more overhead. You have to sit down, you have to write the test, you have to figure out what it is that you want your application to do, and then you have to get the computer to do it for you. But it's fast. Once you have that test, it runs in milliseconds. All of your tests on a very large site can run in seconds. You can get it done all in under a minute. And you know that every single time you run those tests, it's going to be the same set of tests. You're going to be ensuring that that behavior exists across the site. And that is an incredible advantage. So when we talk about testing in this course, I am talking about automatic testing. We are interested in making the computer do all of this work for us. Which leads us to, why do we do it, right? That overhead is not insignificant, so we need to talk about why we are taking the time to go ahead and do it. In some ways, we're already doing it, right? We're just making the computer do it for us. We're just automating this, right? But we are, in fact, already testing our website manually. The second thing is that in a lot of cases, writing the test, that overhead, forces us to empathize with our customers. This is less true with an interface, right, where actually clicking around has a certain amount of value, and so this doesn't replace QA. But when you're dealing with an API, actually going ahead and interacting with an API is exactly how your customers are going to interact with it, right, at the code level. So there is a certain amount of empathy that you gain by writing these tests, and that can actually help you write better API endpoints. Finally, and this is the really big one, the tests allow us to ask the question, does it continue to work? If we change a piece of the program off in a corner, does the rest of the application continue to work as expected? And sometimes you might say, oh, well, I understand what the components are, but what if you're replacing dependencies? What if you're upgrading dependencies? Now, all of a sudden, having those tests that go through and run through everything for you in 5 seconds is very valuable because it makes upgrading really easy, as we will see later. So the way to think about this is actually as if the overhead is an investment. Yes, you're going to take a little bit of time now to go through and write these tests, and it is going to slow you down in the immediate. However, it means that in the long run, it is going to make all sorts of changes, upgrades, everything of the sort much easier, and it allows you to guarantee behavior in a way that manual testing simply does not. So, okay, now we see that we're going to be using automatic tests, and we have an idea for why we want to use automatic tests. So what do we test, right? How do we go about thinking about it? This is usually presented as a pyramid, right? There's a whole set of tests that you want to have all the way at the bottom, which we refer to as unit tests. Most people say, oh yes, you want a lot of unit tests, and then on top of the unit tests, you go ahead and you write integration tests. So the way to think about this is you start with, I just want to make sure this one little piece works on its own, and then you have a whole bunch of the little pieces, and you want to make sure that all the little pieces work together. Great. Now you have a whole bunch of little pieces and they all work together, and the next step is functional testing, right? So if you have a lot of unit tests, then you're going to have some integration tests, and then you have a few functional tests. And this is to make sure that the behavior in the website or the behavior in your application works as you would want it to. Now, this is sort of as you're going, as you are writing the test, or as you are writing your software, but these are not the only kinds of tests that you might have. Sometimes you may encounter a bug. You wrote some tests, you had some behavior, and you forgot to check something, and your users come back and they say, oh, we discovered this thing, it doesn't work as we want. We'd like you to fix it. You go, yes, I would like to fix it, but I would like to make sure that that error never ever happens again as I continue to change my software. This is a regression test. You are making sure that your application doesn't regress into behavior that you never wanted to see ever again. Finally, there is interface testing, sometimes called end-to-end testing. I've seen this actually called a whole host of things. The general goal is, in particular for mobile applications or for website interfaces, you want to say, okay, does my website look right and does it interact correctly in Firefox and Chrome and Safari? Does it look correctly once I'm actually handing it out to my users, or are those not the right colors, or is that not where I want that button to be, et cetera, et cetera, et cetera. So there's a whole host of interface testing that you can do. Now, I note we won't really be getting into the last two. We're going to be really focused on what people think of as the sort of the bottom of the pyramid: unit tests, integration tests, and functional tests. Although we'll see that with Django as a framework, unit tests isn't quite the right way to go about it. In fact, when you think about the right way to go ahead and build tests, with a framework or with an application, it can be tricky to know what to test. When do you decide to write a test? The question I generally ask myself is, does this help make sure I have a better user experience on my application? Does this help me ensure in the long run that my users are going to be happy using my application? If not, if the test that I'm writing doesn't help me ensure that this is going to be a good application, well, why am I writing this test? And if I am writing a feature that my users rely on, well then, I do want to write that test to ensure that it's working. You then have to decide what kind of test you're going to write. Is this going to be a unit test? Is this going to be an integration test? And you'll see that they're generally kind of coupled. You might start by writing a functional test where you say, oh, I would like my website to, or your application to do this. Oh, well, if I am going to guarantee that behavior, well, I need the following integrations. Oh, if I need those sort of pieces to work together, oh, there are these units within those pieces that are integrating. Oh, I need to unit test those, right? So you can sort of come down the pyramid to end up writing a whole lot of user tests that then end up working for you functionally. Another way to think about it is a little bit the way you might think about security. Security, you think about, what am I protecting from? Who am I protecting from? And how do I go about doing it? Testing's a little bit the same way. What am I testing? Why am I testing it? And how do I ensure that this meets this goal for me in the very long run? Now, okay, we've seen why we test. We see what we test, or what those sort of various tests that we can write are. This leads us to, how do we test? Now, I don't mean this in terms of practical information. We'll see that throughout the whole rest of this lesson. I mean this in terms of a methodology. How do we go about not only picking the kind of tests that we write, as I've sort of just touched upon, what is the right way to go about introducing the process of testing into our development process? I've seen a lot of businesses that go ahead and have two different roles here. You have the people who write the application, and you have the people who show up and who help write the tests to ensure that the application developers are doing the right thing. I'm not a fan of this, because usually you generally want the application writer to state their intent. The test acts in some way as a form of documentation for the other developers on your team. They can say, oh, I see, this is supposed to guarantee the following things, does it do it? And so that way in code review, you have the ability to go through and really understand what's going on. If a person is just writing a feature, you sort of lose this documentation. Now, you could absolutely enhance this by having more code review, all of that sort of thing within your organization, but you can see that this is an interesting way of interacting that you would lose if you do this. So I'm not a huge fan. Instead, I'm a big fan of test-driven development. The goal of test-driven development is where you write the test first, and then you get the test to pass once you add the feature, right? You add your unit, or you make sure that your units are working correctly, only after you write the test that ensures that that is going going to work. And this helps with the empathy part, right? If you're doing this with an API, it helps you to go, oh, is this actually the feature that I want, right? If I were interacting with my API, what would I be trying to do with it? And is this the right information to send to it? Is it the right information I'm getting back? Can I use it in the following context? So writing tests in advance can actually help you get your features right on top of that. In this course, we will be following test-driven development, or TDD, the entire way. The entire repository is structured according to TDD. If you look through the commits in GitHub, you'll see that I start by writing a test, so you can see that fail, and then in the next commit, I will try and get it right. I don't always immediately fix the problem or fix the test, right? I don't immediately get the test to pass. I will sometimes make a couple changes until we get the test to pass to demonstrate what's going on internally with Django. The goal here is that a first commit will implement a test, and then ensuing commits will go ahead and get the test to pass. This is not how you want to write production code, right? When you're writing production code, you'll generally have a single commit that will have the test as well as all of the changes, and that helps people understand, yes, in this commit, this is what was changing, this is how the test changed, this is the behavior that was affected, and then we can see that happening in the actual application code. But hopefully by structuring the repository in this way, it helps demonstrate the process as we go about it. And just in case, the next lessons we will actually go through and really step through in a TDD fashion. Just to really hammer this home though, right? We start by writing a test, we then go ahead and we will run the test. Once we have run the test and we ensure that it is failing, and in TDD, you'll sometimes see this be referred to as a red light state. We're going to go ahead and we're going to try and write some code. Now, if we're really good, maybe we get it so that the code immediately passes this test. But often, I have to come back and I have to run the test multiple times until the code that I have actually passes this test. So I end up kind of within this inner loop of this process. And once I'm done with the code, I can go ahead and commit my changes, and then I come back to writing another test and moving on to a new feature, or ensuring that this bug never happens again, and writing a regression test, or whatever it is that I'm actually doing. I want to take a moment to come back to the topic of why we test. Here is a photo of software pioneer Margaret Hamilton in 1969 standing to a printout of all the software that she and her team wrote to get the Apollo team to the moon. She is a software pioneer credited not only with being critical to the moon landing, but credited also for popularizing the term software engineering. In an interview with The Guardian in 2019, she states that the process of building software should also be considered an engineering discipline. I think that as a field, we're still coming to terms with this. But if we are engineering, then we need to implement engineering practices. The topic of engineering ethics and security is outside the scope of this class, but testing is not. In the same Guardian article, they say her rigorous approach was so successful that no software bugs were ever known to have occurred during any crewed Apollo missions. And that is nothing short of incredible. Think of the number of times you load up a mobile app, a web application, something on your desktop, and it goes haywire and you're not really sure why, and there's no recourse to it. And it happens all the time. Software bugs are considered a sort of normal in our industry. Testing is a process that introduces rigor into the software development process. And that is why I think it is so crucial. I can't force you to write tests. I can't force your management team to ensure that you write tests. Only you get to decide what kind of software you're going to write. But I can tell you one thing for sure. I want to write software the way Margaret Hamilton writes software.